A good chunk of people in the Postgres community are probably already doing some sort of query logging and then looking at those logs and getting information based on those. The idea that we're trying to introduce here today is that there's sort of a second layer to that whole idea that is actually a formal concept in a lot of other database systems that we haven't quite gotten to yet in Postgres, and that's the idea of doing formal workload analysis. And there's some new changes in Postgres that make workload analysis suddenly more feasible to do than it's been before. And if we want to follow that path, it's going to ripple out down to how tools get built and just fundamentally how people approach a lot of these problems. So just to get one thing out of the way, here's a starter PostgreSQL.conf file that turns on logging for a lot of things and has reasonable default values for things that are set unreasonably by default. So if you put this in your starting config, you'll get logging. It'll have timestamps on it. You'll be able to analyze those logs usefully via tools like pgfluent and pgbadger. And any statement that takes longer than 1 second to run will be logged in there. And that's that logmin duration statement bit is where that comes from. So the idea is how much detail you get in the log is dependent on that threshold. The lower you set it, the smaller the queries that will show up in the logs are, and the more detail you get about what's happening on your system, but you've just got an increasing amount of data to write in order to log all of that information, and that becomes problematic eventually. So there's another problem here as well I just want to mention briefly. By default, Postgres comes with a text logging thing. When you set up logging, it'll give you default names that are things like Wednesday something followed by a process ID number or when the server started or something. It's hard to say it's the stupidest default in the Postgres configuration file, but it's certainly in the running if it's not. So don't assume that that is any kind of good idea whatsoever. Change that over to some sort of reasonable naming scheme. But the problem is, even if you do that, you still have to worry about these text logs when they're going to get rotated. You need to prune them. The database is just going to keep creating them forever. They'll just pile up, and it's your problem as for how you get rid of them. And there's some very fundamental problems with this. One is if you have multi-line statements, they're going to split across multiple lines in the output file, and you'll be hard-pressed to put them back together again to make any sense out of your analysis of that data. And there's a lot of performance issues. This code is not really optimized to be able to perform extremely well in this situation. And so my basic recommendation is every minute that you spend trying to tweak the configuration for the standard text logging is just wasted time, because no matter what you do, you'll hate it forever, and it'll never converge on a useful setup. So what you can do instead is use syslog. Syslog is also worth hating for many reasons. There's a bunch of different versions floating around. There's syslog and r6log and syslog ng, and every version of Linux and whatever has slightly different configuration files. And I've set up syslog a dozen times, and yet every time I set it up again, it's completely new, like I've never seen it before. But syslog works. It's not that difficult to set up good naming conventions for it, that it saves data every day, it rotates every day, it keeps some number of days worth of data. And once you get that set up, it just works and takes care of itself in the background, and everything is fine. So syslog has a lot more upfront pain than the standard text logging, but when you're done with it, it actually gives you a solution that you can then build query log analysis stuff on that works. One bit of trivia. If you turn on syslog and logging, you may notice that there's this huge increase in how often writes to disk for the logging disk happen. That's because by default, syslog forces whatever log you've written all the way out to disk with an fsync system call after every line of output. It's insane. It's way more disk flushing than is needed for logs. So somewhere in your syslog configuration, there'll be something that looks like this bit at the bottom. It'll say stuff coming in from the Postgres facility, which is local 0, is going into a Postgres log file. That little minus at the minute is the very hard to discover bit that's not really in the documentation. If you put a minus in front, it stops doing that sync thing, and then suddenly normal performance and sanity come back into play. So this is sort of the basics of getting query logs set up. So what people do nowadays is they wait for a day worth of data to collect up, and then syslog or whatever will rotate it, and then the rotation will be in the middle of a day somewhere. It'll be like 4 a.m. So if you take 2 log files and put them together, you then can have a continuous 24-hour real day worth of stuff, and then you analyze them with an external tool. PG Badger seems to be the latest one of these tools that is catching on, seems to be working for a lot of people. It's nice because it also analyzes temp files and some other things that the starter logging config I presented analyzes. So it works fine. PG Fuin is sort of the ancestor of it. Its main problem is it just does not work on big log files. It just chokes on them and becomes a dead weasel. There's also a couple of other log analyzers floating around that are aimed specifically at high-performance log analysis of things that just these other tools choke on. So PGSI was one. There's a C or C++ program called PG Query Analyzer that's written for Fashionista, I think it was, that some people are using. But regardless, the workflow is you wait, you get a whole day worth of data, you process it, you publish it to usually a web page, and then you view it, and you're now viewing the history of what happened on your site the previous day. And that's not really all that useful. Okay, great. PG Fuin shows us these are the queries that took up the most time. We know things like if we're optimizing any query but this top one here that's taking up almost all of the duration, you can spot really obvious query trending problems with this, but if the query pops up in the middle of the day and that's where the problem is happening, you will have no idea whether the run of that query was correlated with the problems you had during the day or not. You're going to have to go dig back down into the log data yourself, or all sorts of crazy things. So this is one thing that has always bothered me. The next is the overhead on this whole thing is really high. You have to realize the query log is a single resource. It's a file. Everybody's writing to it. They have to get locks on it. As the volume of users go up, the overhead of getting those locks, as people wait for the data for the logger to become available, it actually becomes noticeable. And the logs can become quite big, which means that you start having to have difficulties analyzing them fast enough. And the net effect of this is that because the overhead is so high, you may discover that you can't turn the resolution of the logging down far enough to actually capture all of the data that you'd like to have. You basically have to say, I can only afford to log the slowest queries, because if I try to log every query, the logging system itself gets in the way so much that it's just useless to me. And this is the situation that we've been in as a Postgres community for a while now. So here's an honest-to-God example of how this worked. This was a system where logmin duration statement was set to 2 seconds, so not super high, super low, standard sort of thing. If you look at week 35 there, you'll notice there's a little blue spike above that. That's time spent waiting for locks. So this is what happened when, on this production site, I tried to lower logmin query duration from 2 seconds to 500 milliseconds. And just that level of increase, I mean, we're not even talking looking for tiny queries. I'm only half a second or above. You think there wouldn't be that big of a difference, but I had to roll this change back and tell the customer here, I'm sorry, we can't collect query log data for your site at less than 1 second resolution. It just overloads the query logging infrastructure, and there's not really anything we can do about that in the version of Postgres that you're running. So I mean, this is the situation that you end up getting into. And there's another problem here, which is there's things that are missing from this by definition because they were too short to show up on this. So you're missing short queries, even though those short queries might be running all of the time and taking up enormous amounts of resources. You don't see them because of this, because you can't set the duration small enough. Another problem here is that normally when people look to do trend analysis on their databases, they want to be able to graph data over time, and we don't really have that with the approach of any of the tools that people are using right now. Generally, the best anybody's got is you can re-summarize your data at a 1 month interval, say, or a 1 week interval instead, and now you get a larger view of it. But questions like, well, which were the hot days of the week, which are the hot hours of the day, what queries were running them, there's still not really good answers to these things. And storing these things actually becomes quite a chore. If you have a busy site and you store a lot of these things, the numbers can get shockingly big, and how long it takes to actually process them becomes a problem. Because of all these factors, this is not even remotely close to being a real-time operation. There was a dream at one point around Postgres 8.3 that we might be able to log stuff to the CSV log format and almost immediately import it back into the database and then analyze slow stuff almost right after it happened. And I don't know that anyone's actually managed to make that to work. It just doesn't quite seem to work right. You have to use syslog instead, and then when you've got syslog, you've got a whole different kind of import problem. It was just messy. And so one of the real problems here is you log into the system is slow. You'd like to know why. Well, you might have an answer to it if you wait for this report to come out tomorrow. That's not really a useful operational workflow for a lot of people. So this just gives you an idea of scale of how ugly the let's just dump all of the query log text is for a site problem can get. This is the worst one I happen to have around when I was putting this talk together. This is from June of 2011. I don't even want to know how big these log files are now. A busy site, couple of hundred users, terabyte worth of data, even not capturing every single bit of data, you can easily collect up gigabytes worth of data to be analyzed here and just have enormous amounts of time to actually go through and do anything with any of that information. And again, this is gigabytes worth of data, and that was with log min duration statement set at some number of seconds, and all data about short queries was thrown away as just infeasible to even hope to collect. So this isn't even a fair representation of the real server workload, and it's still so big that if I run PG-Fouine, which was the best of the tools seemingly available to me at the time, I discovered I needed a system with 64 gigabytes worth of RAM to process any of these files, or PG-Fouine just ran out of it, because apparently someone thought it was a good idea to keep all of the data about every query in memory in an inefficient structure the entire time the program is running. Not sure how that decision got made, but it clearly was not aimed at processing 2 gigabyte log files. So, if you step back, what do we really want? What I want in most of the work that I do is real-time data. The real-time data for me is normally 5-minute snapshots taken via programs like Munin or Cacti or other programs like that. And then I put them together, and now if I've got snapshots of the data at 5-minute intervals, I graph them along with snapshots of other data at 5-minute intervals. So disk I/O, CPU usage, all this other stuff. And now I can directly correlate database trends with things that happen in um, on the rest of the system. So it's also nice if you save the data in a way that you can aggregate it, because you start by wanting 5-minute trends, but then you also realize, well, really I want to see like a daily trend, a monthly trend, and a yearly trend too. So however you do this, it would be nice if you could aggregate it without having to go all the way back to the original log data and reparse that again, which seems to be the approach that's the only one available with any of these other tools. And the final bit here is sort of an assumed part of all of this is that you're getting normalized queries out of this. So normalized queries are where life starts getting interesting. So here's output from PGBench running. It updates, inserts some things, does some selects. The thing to note here is that like these first three statements are doing updates, they're making changes to this bank balance. As a human, you'll look at those and go, those are basically the same statement, just with three different input parameters of some sort, three different constants that have been inserted into them. When you aggregate that, like we saw before, you don't want to see that. What you want to see is something like this that just shows, oh yeah, every time I did that update, it was like this, except the account ID changed, right? Like that's what you want. So this problem of how do you normalize things ends up impacting anything else you do, because if you don't normalize these queries relatively quickly, you can't match that this query is like a normalized one that I've already stored in a way that doesn't cause the storage to just get completely bloated to the point where you can't keep track of it. So if we go through normalization, we take statements like that and we replace the constants with some other placeholder, and here they're question marks. And so now, where here we had three different update PGBench branches, statements that had different values in them, now we've just sort of normalized all of those to be just one that has those values, and that's great. We say that's run 3 times, and here's the average and the other statistics about it. So we wanted to get normalization into the database. What we had starting at the beginning of 9.2 development was this thing called PGStat statements. It had been in there from 8.4 to 9.1. Unfortunately, it only works with prepared statements. If you prepare a statement and then execute it, it takes the parameters out and it knows what to do with it. But prepared statements have lots of performance problems of their own, so a lot of people just can't use them either. So it's not practical for the majority of the sites that I use. If anything, if I'm doing something with prepared statements at a customer site, it's getting rid of the prepared statements because they're getting bad query plans and we have to stop that. But everything else about PGStat statements was right. It saves its results to a bit of shared memory, which is very fast. It persists that to a file across restarts. So it's not completely transient memory information. It does try to save it for you. And you can grab a snapshot of the data relatively quickly because it's just shared memory. And really, the only disk access involved is when you say, I want to take a snapshot and save it to disk somewhere, you pay for it then, but there's nothing writing to disk after every statement or every completed transaction or anything. You're basically saying, if I want 5-minute resolution, this is going to write to disk once every 5 minutes, and that's a completely reasonable level of overhead for most people. So I had an idea. I presented it at the Postgres West last year. I said, programs like PG Fouine, what they do is they have these regular expressions that do query normalization. And those regular expressions, they take constants and they remove them, and they take commas, and they remove spaces around them. They do all this other stuff. And we know that works for people, and the query normalization part is not really where the complaints with PG-Fouine are from. The problem is we can't get real-time query monitoring out of it. But if pgstat statements did real-time query normalization too, suddenly it would work. It would be a useful tool for us, and it would take scraping log file data out of the critical path for needing to get real-time data about what's happening with your system. So I sort of went on stage and I explained this general idea, and I seem to get good support within the community for doing it. And I explained it to Peter Gagan here, and his reaction to it was, I see the problem that you're trying to solve, and that's a terribly stupid way to go about solving it. So now that's why Peter will talk about what he did next instead.
Thank you, Greg. Okay, so we're going to talk about the mechanism through which we go about fingerprinting queries. We don't actually do anything directly with the query text as such, so we take a rather different approach. So internally, Postgres has a certain structure. These are called query trees, and these are in effect a canonical representation of the query. If two query trees are bitwise identical, that means that the two queries are semantically equivalent. So basically, this hashing process occurs between the query parsing and query planning stages of query execution. So this is a quick, efficient way of identifying similar queries. So internally, pgstat statements is associating a hash integer value with each and every entry. It also now outputs a normalized string, but this is just purely window dressing. The normalized string purely serves to make the output more useful for the end user. Yep. So by doing things this way, quite apart from the fact that it's more performant, we are doing things in a well-principled fashion. And this can occasionally come up, and it can occasionally be significant. So what we are in effect doing is leveraging the core system, and leveraging in particular the core system's normalization smarts. So changes in the PostgreSQL parser will automatically be reflected. So PostgreSQL, during parsing, there's a process called parse analysis, through which, in effect, a form of normalization occurs. So we have this canonical representation, which is ultimately passed to the planner. So the query tree is passed to the planner at the main point of input for the planner. So we can do things like use equivalent syntaxes. So, for example, we can use dollar quotes or single, or different types of quotes can be mixed and matched, and the queries will be represented as equivalent. White space doesn't matter. Aliases for relations are not important. They're not differentiators as such. And because we do this after parse analysis, we resolve the OIDs of tables. These are internal identifier values for each and every relation and other internal objects. So in this fashion, we ensure that normalization occurs, or two queries rather are only recognized as equivalent when they are in fact exactly semantically equivalent according to the core system's own definition of that. So we also, while we're at it, we produce this more useful query string where constants are replaced with question mark symbols. There is no risk of accidentally processing the wrong thing. So this is probably best illustrated by, if you're using this order by syntax where you specify order by 1, 2, referring to the columns in the select list, that won't become order by question mark, because, of course, that won't be a constant within the query tree, within the original query tree. And for that reason, quite naturally, we won't canonicalize it in that way. Similarly, if we use this order by 1-2 syntax and subsequently use the order by AB, presuming that they're in fact the same columns, the query will be recognized as equivalent. So we handle all these kinds of corner cases quite neatly, just as a natural consequence of the way we went about implementing this thing. Okay, so here's some output from pgbench for pgstat statements. There are more columns, of course, but these are the most useful ones. So there's the number of calls to the query, its time in milliseconds, I believe, and the actual original query text. This is the dollar. These are prepared statements, so they don't actually have the question marks that you see in 9.2 on.
Swap back in.
Yep.
Okay. So Peter sort of gave you an idea. Not only is parsing this stuff in core faster and as he says, well principled, there's actually some things that it's possible for badly written external query log processing bits to get right. I mean, you can change search path, and that can change how a query works, and there's no way something that's just looking at the logs can necessarily figure all that out. So this is making sure you get exactly the right query that you wanted, and the query planner even does some things where it will convert equivalent things to each other, and we get to take advantage of that. So with this in place, now we have what we need to do, true workload analysis, which means we take real-time snapshots and we can display the data on a time scale and see what's going on with things. And it's similar to what we're used to seeing for other types of data like this. So here's the big reveal slide. This is new. So what we're doing here is this is showing a period over a couple of minutes worth of time, and I'm running multiple different types of pgbench workloads on this system. And what this is showing us is every one of the statements that's involved in this system, the top statements that are being called the most, I am graphing them over time. So we can see from this nice trends like, okay, these green spikes here, those are times when something was heavily running and doing a select from the pgbench accounts table, whereas these other periods here with this blue, red, and purple bit, they didn't have so much of that select traffic. They were instead running these various types of updates. If you're familiar with pgbench, you'll recognize that these are just different modes you can run the test in. But this right here, I don't think I've ever seen queries broken down like this. We've got individual queries, we've got them normalized, and we've got the data such that I can pull it every couple of seconds, actually, if I want to. And I can take a graph like this, and I can update it and make it available every 5 minutes easily. So if someone says the server is slow today and you log into it now, what you see is not just, oh, this is getting pounded by the disk, whatever. It's, oh, these are the busy queries that have been running for the last half an hour. And in the normal workload that has sort of been traditional for this stuff, you have to wait until the next day before the query log analyzer would actually give you any useful data in that form. This is also true just as an alternate way to show the data. We also keep track of how many times everything is called. So this is just showing you that same time period counted a different way. Sometimes the number of times something is called is an interesting value irrespective of the total time that it's involved. keeping track of all of that information. In 9.2, there's also even information about that you can, optional information you can turn on that'll show you how long it takes to access particular files on disk. There's like low-level timing information. There's all kinds of stuff that is exposed by PGStat statements. If you adopt the sort of workflow we're suggesting here, you can take all of that data and turn it into a real-time dashboard that actually shows you what's happening on your database as it's happening.
I believe John Erdman? I'm sorry, I didn't quite catch that. Could you?
I'll get it.
Yeah.
So John's question was, do queries show up in here before they finished running? And the answer is no. If your current production problem is there's a query that's running right now and it's slow and that's causing the problem, you're not going to see it in these logs until it finishes. At the point when it finishes, it can go redraw the graph to show it as having been running that whole time. But in general, that problem we have useful tools for. If the query that's causing you the problems is live right now, you can log into the system and look at it and see it and touch it. The sort of problem cases that I've found are the query that caused all the trouble just ended and someone said the site was slow 5 minutes ago, why? And you want to go back and there's just no way to do that. If it's still running, there are decent tools to figure that out. There's the basic top, there's PG top, there's stuff like that. So yeah, there is a hole in this as far as being completely real time. It might lag by a couple of minutes, but I still think it's very close to real time compared to the, well, we'll get our report tomorrow sort of model.
I'll just add that as a matter of interest, the instrumentation that occurs within executor hooks. So as such, we don't actually include planning time. So that's something to be aware of as well. Yes, sir? I'm sorry, you'll have to repeat that? No, it'll only, if the, okay, so, yeah, in order for the, actually the answer is yes, it will. Okay.
Yep. Rollback statements get durations attached to them just like anything else. I just don't know. You'll probably just see rollback, though, as the statement and not anything else, so that's not. Yeah.
Yeah. Exactly.
Yep.
Yeah. Yeah, that's exactly right.
Yep. So what does this all mean? I think that this capability being in 9.2 pushes the Postgres community in a fork in the road, and there's a good way to go and a bad way to go. What I think needs to happen on the next generation tools here is we need to recognize that right now we have these monolithic tools that parse query logs, and they spend a lot of time doing the parsing of SQL statements and canonicalizing things, getting rid of commas, getting rid of white spaces, stuff like that. If you're getting snapshots out of this new PGStat statements infrastructure, you don't need any of those things. Instead, you just dump snapshots that are, this is the data that was in PGStat statements as of this timestamp. There's a little bit of work to actually turn that into the sort of graphs that I've shown, but it's not so bad. What I think that we need to start doing with the tool community is to take the existing log file parsers that people are using and get them to start outputting that same sort of what I'm calling an intermediate format. If I could run PG Fuin or PG Badger and one of its output modes was something that looks like a snapshot of a normalized PGStat statements, taking a snapshot every 5 minutes, I think that we could come up up with an intermediate format there that both tools could dump into. And now we've separated that whole ugly, I have to analyze SQL problem. And now new tools that want to display this in new ways and whatnot, they don't have to worry about any of those jobs. They get fed normalized queries, times, when they were running, and they can just work on that part of that. And that can be a totally separate tool altogether. So my prediction is that the value of real-time data and getting built-in solo overhead normalization of stuff means that a couple of years from now, every Postgres site that cares about performance is going to be using this pgstat statements normalization stuff, and the idea of logging to a query log and analyzing it is just going to be dead at that point. So people who are working on tools, I would suggest, start thinking about taking the collection and logging and analyzing of the data and the actual graphing and display and the UI of it, separate those two apart and recognize that they don't have to be the same program. They probably shouldn't have ever been the same program. And we need to get a standard for intermediate log data that has been normalized and has timestamps and counts and durations on it that we can then aggregate up further as well. And so this is part of why I wanted to do this talk, was to try to communicate out to more people that this is a direction I see as being almost inevitable because the problems with overhead on the older text-based log stuff are just so large. I just don't think the Postgres community can go in that direction for much longer. So, one more thing. Query plans change over time. Some people get annoyed about that, and they make claims like, well, since query plans change over time, you have no option, you must give me query hints. To which we say, I doubt that. So there's a lot of downside to hints, but underneath the request for I want hints are two ideas. One of them is the query optimizer may not have enough information to be able to execute my query. That's fair, and I think in a lot of those cases, though, the answer is you should learn more about how you can influence the query analyzer, because it is a pretty complicated beast and you can do that. But the second side of the why I want hints problem is people are concerned that they'll deploy the system, they'll get a set of query plans, and then the query plans will change on them one day, and they won't know what happened, and they won't have any ability to retroactively go back and figure that out, because once a query plan changes, you have no clear way to know even that it changed. So you can't go back and ask for the old one anymore. There's no clear indication what happened. So this is a problem when things suddenly get slow. A query plan changing, becoming unstable, breaking is a real possibility. So Peter also started thinking about, can we spot plan changes automatically? And so sure enough, East could do that too. So check it out.
Okay, so I came up with this thing, pgstat plans. It's a derivative of pgstat statements. It solves essentially two different problems. The first one is that the fact is that most people, today at least, are not using 9.2, and many people won't be able to use it for some time. There is internal infrastructure that supports pgstat statements, even though it is an optional contrib module. So if you attempt to deploy the 9.2 pgstat statements against 9.1, it won't work. The code won't compile. So basically, the thing it's missing is hooks that look at query trees. I discussed query trees briefly earlier. But what we do have in earlier versions is hooks for plans. So we can look at things at the plan granularity. So that's one problem. And then we have another problem, which was what Greg just spoke about, plan stability. How do we look at things at the plan granularity if in fact that's what we want? And how do we identify outlier plans among queries, to see if there's been a particularly bad regression in a semi-automated way. So rather than storing a hash of the query tree, as in 9.2's pgstat statements, we store a hash of the plan. We also store the query text associated with the plan that originally produced the plan, which includes the original constants that may have been in the query. Now, we're not doing what we did with 9.2, which is to swap them out with little question marks. We're keeping them because we're going to use them later. And we use them for actually explaining entries within the pgstat plans view. So pgstat plans accumulates essentially the same information as is accumulated in earlier versions, basically in version 9.1 of pgstat statements. So I'm not going to show you the view because it's much the same as pgstat statements. Okay. So we don't. I said that we store the query text with the original constant. This is to facilitate subsequently explaining that query text. Now, when we do that, we can see the plan. And here's an example of that. We're calling this function pgstat plans explain against the pgstat plans view. This particular function it was like a select one sort of statement. So it's basically the simplest possible query, and that just simply has a result node in the default text format for explains. Obviously, the possibility exists for the query text to no longer produce the same plan over time as the distribution of data changes or what have you, or due to any number of other factors, which is why we, in that instance, if we discover that in fact we're not producing the same plan when we explain, we invalidate the entry and mark it as such, and subsequently, if the plan is re-executed, we'll revalidate it and include a new query text, which does actually, is actually representative of the entry now. So essentially, we're maintaining, we're more or less automatically maintaining the validity of the actual query text. Okay.
So this.
Sorry, can I just add one more thing? So there's another view included. It's called pgstat user queries, which itself summarizes the output of the pgstat plans view. So apart from being a reasonable drop-in replacement for what we have in 9.2, albeit an imperfect one with some edge cases that we're aware of and we've documented, you can also use it to identify outliers, because there's stuff like standard deviation, within the query for the average execution time of each plan. Andrew. Well, you're going to see what it. Well, obviously, let's say you get a new plan for an old query. You're going to get a new entry, and then the old entry isn't going to go anywhere until eventually it's evicted from the cache. pgstat plans and pgstat statements have a fixed memory. There's a fixed memory allocation that stores all this information, which limits the number of queries you can have at any one time. Typically, this is set to about 10,000, which,
So basically, there's some period after which where you absolutely can see the old statement and the new statement. Just eventually, the old statement will fall out of the cache just through activity. But as long as you catch the regression early enough, you absolutely can see both query texts. Stephen?
It seems like a very natural extension on PD set statements in 9.2 in terms of combining the notion of having the explain or having the query text parsed out, normalized, given a hash, then you take and plan, after then you go through planning. After you plan it, you take and do the exact same thing with the plan and store them together, so that over time, even if you use that statement, you could actually start to accumulate. Okay, well this query, which actually looks the same as this other query, but the plans changed. Now all of a sudden we see all that. I mean, are we planning that?
I actually did propose that at the developers meeting back in May, but I ultimately decided against putting that in core because, in my judgment, because we don't have a query cache of any kind, really, um, other systems do, and they do something similar. I thought that the double fingerprinting might be an unreasonable overhead, and we also want to do experimental things with this tool, so, for example, there's nothing to stop you from changing the output to JSON or to, YAML or what have you. Yep.
Do we have a mechanism today to? I mean, we have explain, I suppose. I'm just trying to think of how would we store that query plan in such a way. I mean,
That's a hard problem because you're getting into, how do you?
Question from the back?
Yep.
Asking whether we store the range of time the plan was valid.
The answer is no. That's something we could consider. This, I should say, is under active development. We have yet to produce a stable release, and it's on GitHub. It's on GitHub. Contributions are encouraged. Jan? Well, then you get as many entries as there are plans. Now, perhaps I suppose it's plausible that could become infeasible in some situations, but I personally don't think it would. Now, I don't have the experience of having run this thing in production, so there is a certain amount of, this is somewhat speculative in some regards, as to how this is going to be most useful. But again, your participation is very much encouraged, and I will accept all reasonable pull requests. And I think the big unknown about this is how are we going to get the machine readable explains. It remains to be seen how we can best exploit that. For example, we could highlight plans that only use this particular index. That's just off the top of my head. Yeah, Stephen.
So you had mentioned that we added stuff in 9. We added hooks in the right places in 9.2.
Yep.
The use that statements were. We already had hooks in for the planning area.
Mm-hmm.
Is there anything further, going back to the idea that I was hatching a minute ago about combining the two? Is there anything further that would be needed in core to make that work? If we accept the.
I don't think so. Actually, I'm not using the planner hooks. No one actually uses the planner hooks at the moment. They were added in about 2007 to facilitate a index advisor tool, but I'm not aware that that ever went anywhere, although I might take another look at it. We're actually using executor hooks, which have as their parameter a plan. Yeah. So I don't think so, but I wonder if the double fingerprinting would generally be regarded as an unreasonable overhead to pay. Although, it must be said that the overhead of doing this thing is actually not at all unreasonable. It's sort of in the single-digit percents for PG bench output, and so it stands to reason that on any real workload, it's probably something you're not going to care about at all.
I mean, you can always consider making it optional too.
Of course, yeah.
All right, so I have correctly constructed this slide deck such that the slide that generated all the questions was the one right at the end, so we don't really have to care how long the questions took, hooray. we will just end with pointing out that our commercial ad second quadrant R&D is currently working with more core PostgreSQL code contributors than anyone else. And basically, the stuff that you're seeing here is what we were asked for a year ago to start working on, and we've had customers who've been using some of these new cool things for that long at this point. So it kind of makes me sad sometimes that that people sit and work on problems that I thought are solved already and just continue to flog at them. We try very hard not to let our customers beat up on problems that ultimately are futile or are being solved in a better way if you just wait a little bit and do that instead. So feel free to talk with Peter or myself more about this stuff. We have another talk coming up in another room is next up off. Peter's mostly going to be talking about performance improvements in Postgres around write performance. So I'll be hanging around for that, but he'll be doing more of the talking. So that's it for our session, I think.
I'll just add, Heroku actually funded the development of the pgstat statement stuff in 9.2, so thank you, Heroku.
Yep. Heroku, as well as a consortium of people, raised some starter money for the whole thing from the Postgres West convention. There was some small sponsorship to get the proof of concept off the ground. So, I mean, this has definitely been a community effort that a lot of people have been involved in. It's no one person sort of did this whole job. It was a lot of people providing resources, time, help, feedback to reach this point. But I'm pretty happy now that we've reached a point that was not available before, where real-time or close to real-time workload analysis is ready and is quite feasible to start deploying to people as fast as we can get the tools around them built up. Josh?
So you're suggesting it's taking 100 times longer due to either planar regression or a problem with locking or something like that? Yeah. Well, if it was the selectivity, then obviously you could use pgstat plans. If it was something else, then I guess not. Although, sorry, Stephen?
No, I was just going to propose, log iteration might be able to end up taking significant logs still.
Yeah. I mean,
I wonder if you could then extend to have like a min duration. If it goes beyond this amount of duration, we store that query in the table.
well, I mean, we've got log min duration statement. We've got auto explain, right? Right now, we're setting those things to fairly low thresholds because we also need them for query log, like the basics of query log analysis. If this sort of model takes over as the basics for query log analysis, there's still absolutely a role for logging stuff and logging aberrant behavior. But I think that a lot of the situations Josh is describing, the ones I've seen before, the sort of runtimes are so outside of normal that you could set log min duration statement to some fairly high value. You could still get the logs for the really terrible queries in there, but you'd be avoiding the overhead of the bread and butter queries that run most of the time.
Right, but I think what Josh is in part commenting on is that we still require that you go and parse that log file after the query's been logged there. And I think what would be very useful would be to have something pgstat statement like that just operates the exact same way log min duration does, and instead puts the normalized query and maybe even the actual query into a table somewhere.
Okay, you write it.
All I will say is I have written a proposal up that a couple of people have seen for a timing events concept within Postgres, where let's put a log entry every time something unusual related to how long timing on something took. This is the sort of thing that might go into there. You set a boundary and go, this is weird. I did not expect that. If we can get the bulk of query logging out of the way, suddenly anything that's left might go into the exception table, and the overhead of the exception table might be completely reasonable. So that's the direction I'm hoping long-term to go in, but that's a bigger development job than we're going to get done for 9.3, I don't think. And I think we're going to need a lot more community involvement to nail down what exactly that looks like. So, good questions. Simon?
I think the gentleman in the back had a question. Yes? Oh yeah, that's added. It has um, various statistics about the blocks that were altered or touched by the query, um, and it'll even log I/O weights if you enable that at the server level in 9.2. Of course, we weren't able to include that in PGStat plans because the quorum structure wasn't there to do it.
There's that, and then also if you're saving query explain plans, it's possible to request query explain plans that include how many blocks were touched and that sort of thing. So we may end up tweaking this thing so that the form of explain plan that gets saved is the one that shows how many buffers were touched and that sort of thing. So this infrastructure is starting to get there as it becomes available, and we know that's the direction